All right, hello everyone watching. My name is Tamer Abdelfatah, and this is my final project video presentation for computer security concepts. And today I'm going to be talking about the Log4j, the Log4j library, and the vulnerability that was discovered recently in 2021. As I said, Log4j is an open source library, open source Java library, which is widely used in different applications all around the world by many companies, many institutions, and organizations. And its vulnerability is actually one of the greatest security vulnerabilities of recent times. And it has been given the critical rating and the highest threat score possible by the Common Vulnerability Scoring System. And basically, what adversaries could do was that they could send payloads to Log4j or any organizations that use Log4j, and then they could install and execute malware on remote servers. And basically, adversaries were only limited by whatever malware they had on their hands, as virtually anything could have been done when exploiting this. So, for example, attackers did some ransomware attacks, system takeover, or just damaging the system. And one of the first things, or the most important things to understand about the Log4j vulnerability is that it's a zero-day vulnerability, which means that no one knew that there was a problem until people started exploiting it. And this code has been used for a very long time, since 2003, and life went on smoothly until some people playing the video game Minecraft actually discovered this vulnerability, and they discovered that they could create some text strings which could be executed, and these text strings contained malicious code. And then formally, the vulnerability was privately first disclosed to Apache Software Foundation, which Log4j is one of its projects, by Alibaba's cloud security team in November 2021. And just for some context of how the situation was at the time, this was during the holiday period, so everyone went on vacation, and no employees were really, or like the full workforce weren't really available at the time to solve this problem. This is one of the memes I find most interesting about this, because it kind of showcases how much, or the extent to which, this library was very widely used. So people had the most difficult time trying to identify instances of Log4j in their code. So even though this has been identified and solved by most companies, the ramifications of this vulnerability may still take years and years to truly understand its total scope and how damaging it was, because the damage was really unquantifiable. Now I want to talk about the motivation, or my motivation for choosing this specific vulnerability to talk about. What I found interesting about it is the fact that cybersecurity experts call it a cyber pandemic, and that is due to two different reasons. The first one is how quickly it spread. So this graph shows like that by 72 hours, almost 800,000 attempts were done to exploit the Log4j vulnerability. While the second reason is the number of variants that were created. We can see that by 72 hours here, 60, almost 60 variants had been discovered. So I feel like this meme really encapsulates how that felt like for people working in the ecosystem. As soon as a patch was released for one variant, another variant was discovered, and so on. While this graph that shows the percentage of corporate networks that were impacted by the Log4j exploitation, we can see that on average, almost 50% of all corporate networks were compromised during this attack, which is a very huge number. So now let's delve deeper into the actual attack and how specifically the attackers were able to inject malicious payloads into remote servers. So have a look at this program over here. This is a Java program, and basically all it does is that it takes as input the username and then outputs hello and the username. So in this case, the username given as input was malware tech, and then the output was just hello malware tech. So this all sounds easy and there's no problem with that. However, just like done in F strings in Python, input a variable instead of an actual string. And then this variable would be later on evaluated and its corresponding value would be outputted. All of this did not really pose an actual threat until people started using it with something called JNDI, which stands for JavaScript Naming and Directory Interface. And basically, what this does is that it enables you to fetch remote objects from a server and load them. The problem here is that the user can actually input their own JNDI lookups, and then basically they can load whatever they want into the application. So, for example, this code given here loads the calculator program into the application. As since we said the first time this was explored or discovered was in Minecraft, let's have a look at this exploitation actually happening in the Minecraft chat. So this is obviously really interesting to see, and the ramifications now make sense somehow, because in this case, the calculator was loaded onto the server, but using the same logic, the attacker or the adversary can load whatever malicious payload they want. So what that would mean is that a lot of things can be done. And in a honeypot experiment done, or a honeypot trap, which is basically when someone designs and intentionally designs an easy target for to lure attackers in, the honeypot experiment found out that in the Log4J vulnerability, the main attack methods used were just injecting malware and fileless execution, reverse shell attacks, or files downloaded from a remote resource and executed straight from memory. One of the major attacks with a financial motivation was the Unos crypto trading platform, which is the biggest Vietnamese crypto trading platform. And in this case, the attackers actually did a ransomware attack and they demanded $5 million from Unos in order to decrypt their data. While in other instances, the attacks had political motivations, like an attack on the Belgian government, where they had to shut off their servers and quarantine their networks until they understood the scope of the attack being done. The same thing happened with six US state government networks, which were attacked by a Chinese hacking group. So obviously, this is only a few examples from a huge sample of examples that we could have chosen from. So the conclusion here, what should companies, institutions, and organizations do in order to protect against the Log4j vulnerabilities, or basically any zero-day vulnerability that is discovered in code that has been used forever? The first thing, of course, that comes to mind is fast reactions, and this was really difficult at the time because everyone went on their vacations, and not a lot of people were available to fix this problem quickly. But actually, for example, the U.S. government asked their employees to stay over the weekend and to return from their vacations instantly to in order to solve this problem. And other companies like VMware and IBM and Adobe, they all released patches instantly, while other companies like Cisco, for example, scheduled a patch release schedule for over a month. So obviously, fast reactions is one of the most important things to protect against zero-day vulnerabilities. While on the other hand, firewalls are a really essential tool to be used to protect against these kind of attacks, because not only an external firewall that protects the network from the outside world is really important, but also internal firewalls that separate different components of the network so that even if the network has been compromised or a human being has been compromised through social engineering, the damage can be limited and contained. Using the same logic, an intrusion detection system and an intrusion prevention system is crucial in this part so that you can react quickly to the problem and try to really limit what the attacker is trying to do. And similarly, the least privilege or the least access principle is really important so that even if the attacker does compromise a certain user, they're not really able to attack the whole network and compromise it. For the questions part, my two questions are what is a zero-day vulnerability and how does a basic Log4j attack, like the example we followed, would work? And that's it. Thank you.